Well, good day, viewers. Today we have a 2016 Jeep. Looks like a Wrangler. It's here for some differential repairs. We're going to be changing some gear sets in it, higher ratio. But before we start this, I take note that there's a bunch of warning lights on. ABS light is on, traction control light is on, and airbag light is on, as well as low fuel, but I think it's just low on fuel. According to the gauge, it's empty. So we're going to do a network scan just to make sure that there's pre-existing conditions before we start pulling the differentials apart on this thing. So it's automatically detected the new vehicle, 2016 Jeep Wrangler Sport. Pulled the mileage out of 128,000 kilometers. Display fitted systems. And we're going to do a code scan of all computers. And Chrysler usually lets you do that with the engine running. Speed control switch performance, so cruise control issues, maybe a clock spring issue. That would have explained the airbag warning light. Implausible left front wheel speed signal received. Left front wheel speed circuit. Steering angle sensor. System voltage low, battery low, steering angle sensor. Over travel performance. Driver airbag squib 1 and 2, so it's probably got a clock spring problem in the steering column, because these two airbag codes would go along with the speed sensor, or the speed control codes, because I'm sure the cruise control switches are on the steering wheel, and those circuits go through the clock spring. Right low beam circuit control high, lost communication with steering wheel controls. Now that's probably related to the clock spring again. And I don't think the steering angle is, but I could be wrong. I'm not sure where the steering angle sensor is. Tire pressure monitor, system deactivated, winter mode. Aside from that, the only thing we're going to have a look at while we're in the front of this truck is the left front wheel speed sensor circuit. It's probably broken wires or speed sensor problem. So I just wanted to record these were pre-existing conditions before we start doing this major disassembly on this thing. So the customer supplied all the parts for this job. Here's the front ring and pinion set. 4.88's is the gear ratio he's putting in there. There's the pinion gear. And the crown gear. And this is the rear. He has supplied installation kits, shims and bearings. He's got cast covers to put on here in place of the stamped steel covers, front ball joints, front axle U-joints. He already has the front drive shaft off. He's also got a locking differential carrier, but the odd thing is it's already got the pinion and the crown gear installed on this carrier, so I'm wondering if this is a used assembly that he acquired from somebody. I guess I could check these gears and see what ratio this is. I have to give him a call and see, because somebody's already pressed the pinion bearing on here with a shim, and I don't know if that's the correct shim. We're going to have to figure out whether that's the correct shim. So I'll give him a call and see what's going on with this rear. So there's the wheels. Caliper assembly's off. Brakes are in pretty decent shape, but there's no parking brake mechanisms in here. So I'm going to ask him if he wants to restore that shit or just go without it. A lot of guys don't bother. And I'm ready to drain the differential fluid here. I've marked the pinion yoke with center punch marks. Now looking at this one, he's got the drive shaft off, and it's probably a good thing because something's going on in here. I don't know what somebody's been doing with this front differential, but we'll figure it out. He hasn't called me back yet. That pushing looks like it's out of place. I think it's supposed to be centered, but that's secondary. So unlike other Chevys and Dodges, this has got an axle flange and there's no C-locks in the diff, so you got to remove the speed sensor connector and take the nuts off the back here and use a slide hammer to pull the axle. Oh, I just noticed something. Got to undo this speed sensor, otherwise it might get busted. I assumed that the backing plate was going to come off, but it's not. So the speed sensor is hitting this flange here. It's a good thing I didn't force it, otherwise it would have busted it. Now that'll be a challenge to get this speed sensor out of here because it usually rusts into the housing. So I managed to get the speed sensor out by gently prying on it here and pushing on it here at the same time. Now it still won't come through the hole because it's full of rust, but that'll at least clear the flange here now. I was thinking that this backing plate assembly was going to come off, and it should have theoretically, but it's rusted onto the axle flange. So that's how you have to remove the axle. And I think we'll try and get this speed sensor out of here so that we can clean the rust in the hole. So this side's got the parking brake shoes in place here. So I go into the speed sensor and then on the ear of the speed sensor and just push on it gently. Like that. If you try and twist that out of there, you're going to break it off. So now I can take the flange nuts off and this parking brake will stay here. Now would be the time to change these parking brake shoe assemblies. This one's missing the anchor pin. It's probably all seized up. It was disconnected anyways. Now I've marked the caps in here. So now would be the time to change these parking brake assemblies. The dealer sells a complete backing plate, parking brake shoe, actuator, everything all as a kit, pre-assembled. This one's missing an anchor pin. The other side's missing altogether. Both sides were disconnected. But I also noticed something else in here. This got sided play on the carrier bearing, so it's lost its preload. Now I've center punched this one 1 and 1, 2 and 2, so that it can maintain the orientation of the caps. I hope the case isn't damaged from the shims spinning in the case. So I used a cold chisel to knock this loose in here. Put 3 notches in it, so I've got it loose. You can't just tap on this tin part because that'll pop off. You got to keep this together. And we're gonna push it up and tie it up in there because it doesn't need to come right off the truck. So it's a constant velocity joint. So I use a big tie strap to hold the drive shaft up. Took the 34mm nut off the end of the pinion yoke and tapped the pinion in. Normally I'd use a puller, but I'm not worried about this pinion. There's a slinger in here we need to save. So I'm gonna pry this seal out, get this outer bearing out, and then knock out the inner and outer races. Don't understand why this thing has lost preload because the bearings don't look that bad. That's the side bearing, and that's the side bearing. Now it has steel shims in there, and normally they're cast shims. So I think somebody's had this differential apart before. Because normally, in my experience, unless this one's different, they're normally a cast iron shim on the side bearings here. So that shouldn't be too big a problem. I do have shims. So now we need to knock the bearing races out with I use a piece of 1/2 inch square stock. And that's the bearing races out of the case. Where is the bearing race? There it is here. Let's have a look at it, see how it looks. It was a little bit rough when I was spinning it. There is some wear on it. That's the front bearing race. And this is the rear bearing race here. There's some wear on it. So now we clean up the case, wash it all out, and begin the reassembly process. So I'm cleaning this housing out, and this is why it's so important that you clean. That's metal filings. So this, and there's not that much bearing material in there. So this has definitely been worked on, I think. At least it's sure. There's a lot more metal filings in there than is wear on the bearings. So I wonder if it's had a bearing job done on it before. But nevertheless, it wasn't cleaned very well if it was. Oh well, that's why we're here. So this is the bearing kit was supplied for the rear. That's the front pinion bearing. No, that's one of the side bearings. That's the front pinion bearing race. And there's a bunch of shims with it, and the crush sleeve, and the pinion nut, and crown gear bolts. That's fine, but where's the pinion seal? Normally there's a pinion seal included with this. Here's the front one, and there's the pinion seal with the front. No pinion seal. So that's going to be a problem. But we also need to replace those backing plates and parking brake shoes as well. So I guess we'll make a list and see what we're short. So we're pressing the original pinion bearing off the pinion so we can see what shim is in there. Gives us a good place to start with the pinion depth. Pinion depth is based on the case, so we should be okay with the same shim in the new pinion. At least I hope so anyways. So there's the original pinion shim, and it's 49 thou. That was between the pinion bearing inside here, and that sets the pinion depth. So I'm trying to think now if I should go to the trouble of figuring out, this one says +2. Figuring out the pinion depth, or just install that shim and see how it works out. Sometimes what I'll do is put it together with the bearing and the shim, and not put the crush sleeve in, because you can only use the crush sleeve once, not use the pinion nut, not put the pinion seal on it, and set the bearing preload with the old pinion nut, and then check the pattern and see how it is. And if it's okay, take the yoke off again and put the crush sleeve in and the new pinion nut and the pinion seal and put it together. So I'm installing the bearing races. I don't have exactly the right bearing installer, so I'm using this one but backwards. It's pretty close. You can use a steel punch. In fact, I might have to. I think it's cocked a little bit. So I'm going to try tapping the bottom of it. This is a soft steel. Let's check the clearance. Seems to be going straight now. Maybe on this side. Let's try that driver again. It seems like it's bottomed. Yeah. Make sure there's no aluminum from that piece. I'm going to look in there, make sure it's bottomed. I'm pretty sure it is. Feels like it is. Okay, now we can put the pinion in. So there's a pinion installed with just the bearings and the yoke and the original 49 thou pinion shim. I didn't put a spacer in there, and I didn't put the pinion seal in yet because I'm going to test fit and run the pattern and see how close we are. So I may have to change that pinion shim. The setup for pulling the side bearings off. There's one side bearing. Now we can pull the other one off the other side. Some guys use a torch and cut them. I don't like to do that. So that's how you take the side bearings off. I'm going to clean up the case. I'm surprised he's not putting a locker in the rear. Oh well. So I thought that bearing came off quite easy. Normally it doesn't come off that easy, and if you look here you can see that this bearing has been spinning on the carrier, on the case. It's actually wore into the case here. That's why there was so much side bearing preload, or loss of preload, so much side bearing play. Right? I didn't see the wear on the bearings to cause that, but this bearing slips on here pretty easy. So that's a problem. That bearing's supposed to be a press fit on there, and I doubt it's the bearing that's worn because the bearing is pretty hard steel. It's the case that's wore. So this might be a good opportunity for him to upgrade into a locker. I mean, I can re-shim it, but what if that bearing starts spinning again in there? I better talk it over with the customer. Here's a better look at that wear. You can see where the bearing's been running on here, and it's wore into the case here. Like I said, I can press a new bearing on there, but I don't think it's going to be very tight because this is worn. Again, nice time to change out this carrier for a locker. So I spoke with the owner last night, and he's decided that he's going to replace this case, so I'm going to have to wait a couple days to get a new one. I'm not sure if he's getting an open diff or a locker, but that's his choice. And we're going to go ahead today and proceed with the front. Now this front carrier is a used part that he purchased from somebody, so we have to change this crown and pinion and use the new crown and pinion that he has in here. We're also going to do front axle U-joints and upper and lower ball joints while we have the front diff apart. So I got the steering knuckles disconnected with the tie rod ends and tied up. I got the brake caliper off. Brake pads are about 25% left. Rotor off, wheel spacer off. Look what we got here. So the first bolt I try to take out snaps off like popcorn. So I'm going to heat these ears with a torch, and hopefully that will release them. And maybe we can get this one piece out of here afterwards, but we'll cross that bridge when we get to it. We'll see if the other ones. Last time I did this, I had to replace both wheel bearings on a good friend of mine. Got the upper and lower ball joint disconnected. If the cotter pin doesn't come out, just turn the castellated nut, it'll shear it off. Just break off the outside piece so you can get a wrench on it. So let's get the torch in here and see if we can heat this up. So that's the left side off, heating those ears up on the bearing. Help the bolts come out. This axle shaft is full of sand inside, but that's minor. And this lower ball joint has got play in it. It's not greasable, and you can see there's not much grease left in it. So we're changing the ball joints while we're here. Look at how this brake hose is stretched to the limit because of the lift in here, and so was the wheel speed sensor wires. Now this wheel speed sensor on the left side was setting a fault code, and I don't see anything physically wrong with it. I noticed that it was tie wrapped together, the connector, but we'll have a look at that after the fact. So we got the caliper and rotor off the right side, and this bolt's missing. It's already broke off, so you can see the end of the bolt is in there. So this guy's been driving around with two bearing retaining bolts. Wow. Anyways, we're going to heat this up and see if we can get these bolts out. So there's the front diff cover off. There was next to no oil in this thing. The side bearings are shot. Pinion bearing has lost its preload as well. So it's a good thing that we got pretty much everything to put in here. So do you think that's a problem? There's the pinion bearing. You wonder why it lost preload? I just hope it hasn't damaged this differential housing, because sometimes when that kind of catastrophic failure of a bearing occurs, the bearing race starts spinning in the housing. Wow. So how to release the ball joints from the steering knuckle. Take both nuts off completely and thread them back on a couple of threads, and then hit it here. Just like that. Now it's released. Or maybe this one did release. There it goes. Oh, almost dropped it on the floor. And we're going to replace the ball joints. This one's a little snugger. It's full of rust. Full of rust. So it was a good call to change the ball joints while we're in here. Now we got to clean up the housing. So there's the housing all cleaned. I used Varsol and brake cleaner, and it's really important that you get inside these little pockets here, because there's all kinds of little places for stuff to collect. And blow it out, blow it dry. Got the bearing races out, got the axle tubes cleaned. Blow through them and push a rag through them. Gasket surfaces cleaned. So next is to install the side seals. So I usually put this seal in first with a long tube and a helper to tap it in, and then I put the short seal in on this side through the original seal. Install the bearing races. So I installed the left axle seal first with a seal driver and a piece of exhaust pipe through the tube. I put some Teflon pipe thread sealant on the seal as well. Now we'll do the right side, going through this hole with a smaller pipe, obviously. So the large pinion bearing cone has a slinger behind it that gets damaged when you take it out, and the other one doesn't. So make sure there's no burrs in the case. We're going to use this seal driver or this bearing race driver to tap that bearing in. So use the bearing race driver to tap this in. You can tell when it's bottomed, bounces back. That bearing was nice and tight in there, so the housing is fine, fortunately. So now we press the bearing off of the old pinion to see what shim is in there. So I've adjusted the pinion bearing preload till it's roughly 30. It's about 35 actually, but it's got to come apart again. I put it together without the spacer, without the seal, and I'm just going to test fit the carrier in there. It's roughly 35 inch-pounds, which is a little too high, but again, it's got to come apart. And then the side bearing preload is an additional 7 to 10 inch-pounds, so we'll figure that out when we get the side bearings in. So there's the new side bearings pressed onto the case, crown gear installed, bolts torqued to 80 foot-pounds in a crisscross pattern, and we're ready to put it in. I'm going to try using the original shims and see how that works out. So I put the original shim back in on this side, and I tapped this one in partially, and I got no backlash, so I've got to reduce the shim thickness. But just judging by how tight this shim goes in, I got to maintain this overall shim pack thickness, add the two together to maintain the preload. I think that's pretty good, maybe a couple thou less. So I'm going to take this one out and measure it and see what it is, and decrease it by about 4 thou. So I had 119 thou. I put in 110, so that's subtracting 10 thou or 9 thou from this side, and I left the 139 thou that was on this side. So it was pretty tight going in, and we got about 6 thou backlash, and the spec is 5 to 8. So we're going to run a pattern on that and see what the differential pattern looks like. Well, that's pretty decent. It's a little high on the tooth, but that's the drive side, and the coast side looks good. It's in the center, and it's a front diff, so it's not as critical as the rear. So we're going to let that go, which means we got to take it apart again one more time and put the collapsible spacer and the pinion seal in and the proper new pinion nut on, and set the bearing preload. So I made a holding fixture that bolts onto 2 of the flange bolts. I've got it adjusted to about 15 inches of rotational torque, and I'm going to just tweak it a little bit more. That's it. Maybe just a bit more. Okay, the spec is 15 to 30 inch-pounds because it's new bearings. You got to measure the rotational torque. Again, it's a rotational torque, not a breakaway torque. So right now it's about 25 inch-pounds. So I'd say that's perfect because the spec's 15 to 30. So now when we put the side bearings in and the case in, it should be about 32 to 39. So 7 to 10 more inch-pounds. So 25 plus 10 would be 35. Yeah, we got about 30, 34, 35. And that weighs a little bit less. Yeah, there we go, 35. Well, let's have a look at the pattern. So I ran another pattern. It looks pretty good. That's the drive side. That's the coast side. Let's see what the coast side looks like. Oh. Yeah, it looks pretty good. Anyways, we're ready to put the cover on. And and change the U-joints in the axle shafts and put the ball joints in. So there's the ball joints installed, the steering knuckles back on. Now this lower ball joint has a needle type grease fitting, and the one on this side, which was the same part number, was obviously a different stock. It has a angled grease fitting, which may not be, there may not be enough clearance for that for the U-joint. They give you a plug to put in there if there isn't. Anyways, these are pressed in, of course, Loctite on the nuts, on the tie rod ends, and we're going to change the U-joints in the axle shafts and reinstall. I'm going to check the U-joints. If he's got U-joints with grease fittings, we'll put them in. If not, we'll see. So I elected not to change the U-joints. They're perfectly smooth, and the new ones he's got are non-greasable. So there's no advantage to changing these. There's no signs of any kind of wear or fatigue in them. I did put a hose clamp on the vent hose, made sure the vent was good, because if you look at these original bearings here, look at this mess. That damage is caused by water in the differential. So this has had water in it at one time for sure. So we're going to wait for the rear differential case, and I'm going to have to get a couple of wheel bearings and a couple of hub bolts. I don't like these bolts. They're pretty brittle. Got two broken ones and one with the threads galled on it, so we need at least 3. I'd like to replace all 6 just for safety reasons, and 2 wheel bearing assemblies as well. So I go to put this drive shaft back on this Jeep, and the splines are seized solid, so I sprayed some penetrating fluid. I'm going to take the grease fitting out and put some penetrating fluid in through the grease fitting and see if I can work this back and forth, because that's not good. The spline should be able to move freely, otherwise it's going to put a lot of stress on the drivetrain components. So I got the grease fitting out and I sprayed some penetrating fluid in there, and I'm trying to get the shaft apart so I clean up the spline. Wow. As you can see, it's pretty seized. So I got the shaft apart. I marked it with 2 center punch marks here and here so that we can maintain the phasing. It has a double cardan joint at this end, and it seems to be in good condition. Looks like an aftermarket shaft. Now it's got Teflon coating on this part of the shaft, so we can't clean that, but I'm going to clean the rust up on here and try and clean it up inside there with a small file. Well, I managed to clean it out, and I used a file inside to clean the rust out between the splines. This file here, and then blew it out with Warsol and brake cleans, and we're re-indexed again with the marks so we can put it back together.